All right, welcome to Lab 4. So this one is exciting because starting this lab, you can work in pairs. So that's groups of 2 and just on these virtual machine labs, okay? So you may find another partner to work on all this stuff with you, okay? If you would like, it's optional. You can assume that for the rest of the semester you can also work in pairs for future labs, unless I say otherwise for some particular reason. If you do choose to work in a pair, please, you both should still submit separately to the auto grader. Once you're done, that makes it a lot easier for me to grade you. And then you should also definitely include a comment in your code saying who you worked with. That's how I can make sure you didn't steal it from somebody else, okay? That is the idea. And if you are wondering maybe about how to best ship your code to somebody else, to your partner, and have them send you their code and like reconcile all that, feel free to talk to me. I have some ideas. There's some standard ways of doing that if you can't think of anything. Otherwise, I trust that you will figure it out. Okay. And then, of course, definitely you can totally feel free to post on Discord to look for a partner. That is the perfect place for that. So, let's first get started by getting the starter code as usual for Lab 4 and all that. And then before I show you all the secrets inside of these 3 files, I'd like to teach you something on the terminal and in a separate program. And this thing I'm about to teach you has everything to do with what you're about to do in your first part of this lab. Okay, so let's go to the terminal and my editor very quickly. I have made a silly looking file, and that is to teach you this weird trick. Okay, the first weird trick is cin. If you use it, it actually knows if it succeeded, and it gives back true if it succeeded. Okay? Cin knows. Maybe I should write that somewhere. Cin knows if it succeeded in getting stuff from the user. It knows if something went wrong, and one of the things that could have gone wrong is you reach the end of what's called the file, okay? The end of the input, let's say. So cin gives back true if everything worked out. To successfully get input, it gives back true, and it gives back false if it didn't. So you can do this weird looking thing where you can get a number n from the user with cin. I mean, this gets run, it gets the number if it can, and if it succeeds and it actually got the number, we'll go ahead and hit the if cases body. Otherwise, if this failed, we'll hit the else, and we'll say, okay, there was no number to cin, and maybe I should comment that out for now. So let me show you this. Let me show you that it's possible for it to not get the input and for it to know that it didn't get the input. Okay, so let's do this. So it's waiting for me. It's sitting right here trying to get the cin for a number. So let me type 42 and enter. And bam, did it get the 42. That's fine. It was happy. I can rerun this program and type a special character on the terminal. If I type Control D, that sends the what's called end of file character. And that tells cin that the input is over. The file that is my input is over with. So Control D. And it knows that it failed. There was no number to cin. Cin became false. And this is very, very interesting. And we can use that to our advantage. Let me comment this out now. Let's find the sum of a bunch of numbers like this. We can use a while loop with cin inside of it now. We're crazy like that. We can repeatedly get numbers from the user while we haven't reached the end of file character. You see that? That's beautiful. So each time get an n if we're successful. The second we aren't, we're done. Add that to a sum variable, and then, then print out the sum that you have built up. So that's a bit odd, I know, but it's going to work. cin. Are you ready? So let's recompile, rerun. So now it's going to keep on trying to get input. cin. Okay, 42. Oh, cin again. That was true. It added it to sum. Now it's going back here because it keeps succeeding. 43, 44, enter. Once you're done, you can type that end of file character to make this expression false. It knows when it sees that weird thing, that weird character, because it wasn't able to successfully get a number, another number out of the keyboard, out of CN. And then it knows, after I type that special character, the end of file character, it's like, okay, yeah, the sum was 129. That was everything that you wanted me to do. Program's over. Isn't that weird? That's really cool, though. And it's very helpful for what I'm about to show you, because you're about to make a program that calculates the longest word in a file. Okay, so I have given you a bunch of files. One is shakespeare.txt, and you can make your own. I think I actually only give you shakespeare.txt, and it's up to you to make your own, sorry. But this is what happens. You can have a while loop where you keep on getting words from a file this time. So here is how you can give a file as input to a program. You can use this less than sign to give a file. It tells the terminal to give the contents of a file as input to the program. Okay? So this is from the terminal. You can use this less than sign and just like shove a file as input to this program. So let me show you that. That's very interesting. So I think I've made a file called input.txt, and I've given it 5, 7, and 9, and -1 just for good measure. And this is the entire file. Okay? Watch what I'm about to do. Run the program, less than sign, it's like an arrow, give input.txt as input to my program, please. As input, that it would see through CN. Go. And look what happens. It read that file, it got it all as input, and it saw the end, because the end of the file is part of every file. It sent it to it, and then it calculated the sum. Wasn't that interesting? So you can send files as input and keep on using this fancy way of getting input, because it will eventually stop once it reaches the end of the file. Okay, so that's a neat little trick, one in C++, one in the terminal, to use files as input and to stop once you've gotten all of the input of the entire file. Okay, so that's how you can send files as input to your programs. And so now this program is going to write itself. You're going to edit longestword.cpp, and you can give it any file. Here's shakespeare.txt, which I've given to you. And you're going to go through every possible word in the file with a while loop. And you're going to go and look for the longest word in the entire file. And apparently it's this one. Okay, so that's what you should be getting back once you find the right answer, the right code. Okay, so this is the entire longest word and includes that semicolon. Okay, so this is what's going to happen. Let's look at longestword.cpp now. Okay, so here it is. This is all you're going to do again. So you are going to keep track of your current word and keep on reading into it. And I think you should include string as well. Might as well give that to you now. There you go. Now, what you do after that is you'll repeatedly get words, not numbers, through CN, and this will work because you're giving input from a file to your program. You can also input it manually, and remember to do the Control-D at the end. And then what you output is the longest word that was in the entire file. So your current word variable will go through every possible word. You'll just remember the longest word. Maybe you'll need a separate variable. Okay? So that is all that you have to do there. So give yourself a bunch of tests, make your own little files, give them to your longest word program after compiling it, and see if you can make it work. Okay? With the input from the file, please try every word, see which one was the longest, and print that back out in a pretty way. Okay? So that's calculating the longest word. Some fun new tricks there. Okay? Then after that, it's all about vectors. Okay? So you're going to edit Vectoroperations.cpp, and this one's going to use a bunch of command line arguments. Okay? So you're going to run it, and the vector that you build up will hold 1, 2, and 3. Will hold 2, 5, 4, 0, 3. So let me show you that. Let's edit that file. There it is. So you can put all those numbers from the command line arguments into the vector v. Okay, so you get like the 1, 2, and 3, and you put it in the vector v, and then it's your job to find the min, the max, the index of the min, the index of the max, the second smallest element, and the second largest element in the vector v. And they could be the same if it's size 3 like that. Okay, so that's all you have to do. Get all of those numbers out of the command line arguments, put them into the vector v. Remember, these are strings. Let's put that like that, as I taught you how. These are strings, and you'll have to make ints out of them. How do you do that? Think about that. So you'll read them all into v, all the command line arguments, and then you're going to find the min of the vector. Find the minimum element that's in it, find the maximum element that's in it, and find the, you can probably do this at the same time as you find the min, find the index of the minimum. So for example, this one, the minimum is 1, which will be at index 0 of the vector. This one, the minimum is 0. It will be at index 0, 1, 2, 3 of the vector. You see that? But the min itself, the element, is 0. The index that it lives at is 3. I hope you see the difference. So the min, the max, the index of the min, the index of the max. And then I want you to find the second smallest and second largest element, and duplicates count as separate elements. So like if it were 1, 1, 1, still the second smallest would be 1. And same for the second largest. Okay, so think about how you might do this. There is a trick from lecture that I think you can use and take advantage of. But please yell at me if you have any questions about that. So yeah, you're just reading a bunch of numbers from command line arguments into your vector v, and then you're finding all of these things about that vector. Okay, so compile that as normal and try it with a bunch of examples. Try it with these, try it with your own, make sure it's working properly, and yeah, I think that's all. So you can guarantee, you can assume that the vector that you're given has at least 2 elements, because you're going to need that to find mins and maxes and second largest and second smallest things. Okay, so only give it at least 2 elements. Don't go any smaller, because then bad things will happen with vectors. Okay, so use those assumptions to your advantage and perform all these vector operations, and then you are set. Okay, so go ahead and submit as normal. Once you're done, submit both files, longestword.cpp and vectoroperations.cpp, and you'll give it to lab 04 at CSCI 40, okay? Because that's the new lab. And here's the rubric as usual. The vector operations are a bit more involved, and so that will be double the points as compared to longestword.cpp. Okay, so that is everything I have for you, I think. Please yell at me if you have any questions. This is going to be really fun, especially working through all of Shakespeare. I'm legit giving you the entire works of Shakespeare, starting with his sonnets, okay? All the way through all of the plays. And you're going to find the biggest word in all of that, okay? So, yeah, that's everything. Feel free to find a partner and work on this lab together with someone. That is optional, though. You do not have to. Yeah, before I keep droning on, I will stop myself short now. So I will see you in the next lecture.